So now I again came back to the original discussion. So remember, we derived this differential equation, and what we assume that the motor torque is going to be the constant, and we derive all the formula. For an example, velocity or the speed of the vehicle as a function of time t, the distance covered by the vehicle as a function of time t. But now that derivation is no longer valid, because now I am talking about the constant power mode, not the constant torque mode. By the way, we derive speed of the vehicle as a function of time t, but let's say I want to write time as a function of vehicle speed, then this will be this formula for the constant torque mode. So time is equal to 1 by 2 into root over a into b natural logarithm into root over b by a plus speed of the vehicle divided by root over b by a minus speed of the vehicle. Just keep this formula in mind. We will use for calculating time in constant torque region. Now let's move to the derivation with the constant power mode. So remember this expression where we wrote the total traction force or total upward force from the motor will be equal to all the resistance force which is coming on the vehicle. What are the resistance force coming on the vehicle? The first resistance force is the gravitational resistance force. When the vehicle is trying to climb on the road, the gravity is trying to pull back. The second resistance force is coming when the tire starts rolling due to rolling resistance. The third resistance force, which is the due to the air which is acting on the front of the vehicle, and the next resistance force due to the linear acceleration and also due to the angular acceleration. So this all we have already seen it, and the next what we did, I just wrote the formula for each and every reactions force here. So nothing but here in this steps what we did, we define A as a dv upon dt here, that what you can see I have written here. Now this is very interesting steps here. Why? Because here I have multiplied both side with the velocity or the speed of the vehicle. So this is the traction force multiplied by the velocity or the speed of the vehicle. What will happen if we multiply? We directly write the motor power. Why? Because force into velocity will be the power, and hence the power will be constant either at the motor or at the wheel and everywhere, and hence we can write this as a motor power. And then finally we will end up with this expression. What is the expression? mg into v into sin theta plus rolling resistance coefficient multiplied by cos theta plus 1 by 2 rho into frontal area into drag coefficient into v to the power 3 plus m into v into dv upon dt. Now let's move. So here what I did, I just took all this expression towards the right side here, and then also I divided with mass of the vehicle here in this step, and simply we can write this expression like this: c minus d into v minus a into vq is equal to v into dv upon dt. What is c? Is another constant we define, the motor power divided by the mass of the vehicle. This d we can represent with this formula, which is g into sin theta plus mu r cos theta, and this a is the, again we have already seen, which is equal to 1 by 2 into mass of the vehicle into density of the air into frontal area of the vehicle and the drag coefficients. And then finally we can end up with this differential equation, which is dt is equal to v by c minus dv minus a v q.